Hello everyone, welcome to the new session on manage and control traffic flow in your Azure deployment with routes. We were discussing chapters, part of AG104 preparation. We were in AG104 manage virtual network section. We discussed all these parts in our previous videos. So let's continue with our preparation today. Manage, control traffic flow in Azure deployment with routes. So in this module, you will identify the routing capabilities of an Azure virtual network, configure routing within a virtual network, deploy basic network virtual appliance, configure routing to send traffic through a network virtual appliance. Let's start. This unit consists of 3 exercises, which is very good for us for learning purpose. A virtual network lets you implement security perimeter around your resources in the cloud. You can control the information that flows in and out of the virtual network. You can also restrict access to allow only traffic that originates from trusted resources. Suppose you are the solution architect for a retail organization. Also suppose you are an organization recently suffered a security incident that exposed customer information such as names, addresses, credit card numbers. Malicious actors infiltrated vulnerabilities in your retailer's network infrastructure, which resulted in loss of customers' confidential information. As part of a remediation plan, the security team recommended adding network protections in the form of virtual appliances. The cloud infrastructure team must ensure traffic gets properly routed through virtual appliances and gets inspected from malicious activity. This model identify routing capabilities of Azure Virtual Network, configure routing within a virtual network, deploy basic network virtual appliance, configure routing to send traffic through a network virtual appliance. Let's see. Identify routing capabilities of an Azure Virtual Network. Next unit. So, to control traffic flow within your virtual network, you must learn the purpose and benefits of custom routes. You must also learn how to configure the routes to direct traffic flow through network virtual appliance. Azure routing. Network traffic in Azure is automatically routed across Azure subnets, virtual networks, and on-premises networks. This routing is controlled by system routes, which are assigned by default to each subnet in virtual network. With these system routes, any Azure virtual machine that gets deployed into virtual network can communicate with any other network. These virtual machines are also potentially accessible from on-premises through a hybrid network or internet. You cannot delete system routes, but you can override the system routes by adding custom routes to control traffic flow to the next hop. Every subnet has the following default system routes. Unique to the virtual network 000, internet, 10.008, none, 172 none, 168 none, 164 none. The next hop type column shows the network path taken by traffic sent to each address prefix. The path can be one of the following hops: virtual network, internet, none. A route is created in the address prefix. The prefix represents each address range created at the virtual network level. If multiple address ranges are specified, multiple routes are created for each address range. Internet, the default system route 000 routes any address range to the internet unless you override Azure's default route with a custom route. Any traffic routed to this hop type is dropped and doesn't get routed outside subnet. By default, the following IP4 private addresses prefix are created: 10.0.0.0.8, 172.16.0.0/12 and 192.168.0.0/16. The prefix is a shared address space. Is also added. None of the address ranges are globally routable. So let's read this again. Virtual network. A root is created in the address prefix. A root is created in the address prefix. The prefix represents each address range created at the virtual network level. The prefix represents each address range created at the virtual network level. Okay, I got it now. If multiple address ranges are specified, multiple routes are created for each address range. Okay. The default system route is this routes any address range to the internet unless you override Azure's default route with a custom route. None. Any traffic routed to this hop type is dropped and doesn't get routed outside the subnet. Any traffic routed to this hop is dropped and doesn't get routed outside the subnet. By default, the following IPv4 private addresses prefixes are created: 10.0.0.0.8, 172.16, 192.168. The prefix 100.64 for a shared address space is also added. None of these address ranges are globally routable. Okay. The following diagram shows an overview of a system routes and shows how traffic flow among subnets and the internet by default. You can see the diagram that traffic flows freely among the two subnets and the internet. Within Azure, there are other system routes. Azure will create these routes if the following capabilities are enabled: virtual network peering, service chaining, virtual network gateway, virtual network service endpoint. Okay. Peering, service chaining, network gateway, service endpoint. Okay, these are system routes. Virtual network peering and service chaining. Virtual network peering and service chaining let virtual machines within Azure be connected to one another. With this connection, virtual machines can communicate with each other within the same region or across regions. This communication in turn creates more routes within the default route table. Service chaining lets you override these routes by creating user-defined routes between the peering networks. The following diagram shows two virtual networks within a peering configured. The user-defined routes are configured to route traffic through NVA or an Azure VPN gateway. This is a virtual network, this is a virtual network, this is a peering, and this is another virtual network, this is VPN gateway, from where it is connecting the on-premises. This is network virtual appliance, virtual network gateway. Use virtual network gateway to send encrypted traffic between Azure and on-premises over the internet. To send encrypted traffic between Azure networks. A virtual network gateway contains routing tables and gateway services. Okay. Virtual network service endpoint. Virtual network endpoints extend your private address space in Azure by providing direct connection to your Azure resources. This connection restricts the flow of traffic. Your Azure virtual machines can access your storage account directly from the private address space and deny access from public virtual machine. As you enable service endpoints, Azure creates routes in the route table to direct this traffic. Custom routes. System routes might make it easy for you to quickly get your environment up and running, but there are many scenarios in which you will want to more closely control the traffic flow within your network. For example, you might want to route traffic through a network virtual appliance or through firewall. This control is possible with custom routes. You have two options for implementing custom routes. Create a user-defined route, user border gateway protocol to exchange routes between Azure and on-premises network. User-defined routes (UDR). You can use user-defined route to override the default system routes to traffic can be routed through firewalls or NVS. For example, you might have a network with two subnets and want to add virtual machine in the perimeter network to be used as a firewall. You can create user-defined route so that traffic passes through the firewall and doesn't go directly between subnets. When creating user-defined routes, you can specify these next hop types. So, virtual appliance, virtual network gateway, virtual network, internet, none. A virtual appliance is typically a firewall device used to analyze or filter traffic that is entering or leaving your network. You can specify the private IP address of an IC attached to virtual machine. So that IP forwarding can be enabled, or you can provide the private IP address of internal load balancer. Virtual network gateway used to indicate when you want to route a specific address to be routed to virtual network gateway. The virtual network gateway is specified as a VPN for the next hop type. A virtual network used to override the default system route within a virtual network. Internet used to route traffic to a specific address prefix that is routed to the internet. None used to drop traffic sent to a specified address prefix. With user-defined routes, you cannot specify the next hop type virtual network service endpoint. With user-defined routes, you cannot specify the next hop type virtual network service endpoint, which indicates virtual network peering. Okay. Service tags for user-defined routes. You can specify service tag as the address prefix for a user-defined route instead of an explicit IP range. A service tag represents a group of IP addresses prefixes from a given Azure service. Microsoft manages the address prefixes encompassed by the service tag and automatically updates the service tag as address change. Thus minimizing the complexity, frequent updates to user-defined routes and reducing the number of routes you need to create. Border Gateway Protocol. A network gateway in your on-premises network can exchange routes within a virtual network gateway in Azure by using BGP. BGP is a standard routing protocol that is normally used to exchange routing and information among two or more networks. BGP is used to transfer data and information between different host gateways, like on the internet or between autonomous systems. You will typically use BGP to advertise on-premises routes to Azure when you are connected to an Azure data center through Azure Express route. You can also configure BGP if you connect to an Azure virtual network by using a VPN site-to-site connection. The following diagram shows a topology with paths that can pass data between Azure VPN gateway and on-premises network. Okay. BGP offers network stability because routes can quickly change connections to send packets if a connection path does go down. Route selection and priority. If multiple routes are available in route table, Azure uses the route with the longest prefix match. For example, if a message gets sent to the IP address 10002 but two routes are available with 10000 10024 prefix, Azure selects the route with the prefix because it's more specific. The longer the route prefix, the shorter the list of IP addresses available through the prefix. When you use longer prefixes, the routing algorithm can select the intended addresses more quickly. You cannot configure multiple user-defined routes with the same address prefix. If there are multiple routes with the same address prefix, Azure selects the route based on the type of the following order of priority: user-defined route, BGP route, system route. Let's check the knowledge. Why would you use a custom route in a virtual network? Yes. Why might you use virtual network peering? Wait. Yes, perfect. we completed this chapter. We have an exercise. Let's see how it goes. So we have to create a root table, custom root and subnet. Then associate the root table with the subnet. Let's see. The first task. The first task is to create a new routing table and then add custom root. Okay, loading. So we will be creating a root table here. So create custom root. So this is the custom root table. So we will be creating a root table. Virtual network and subnet will be created. Okay. Then we will list the subnets. Assign the root table with the public subnet. Like that. Wait. The next chapter is what is a NVA. NVA is a network virtual appliance that consists of various layers like firewall, WAN optimizer, application delivery controller, routers, load balancers, IDS, IPS, proxies. Once we we'll work on this exercise, we will go and discuss the next chapter. So we'll be creating root table. Create, and we'll be adding a root. What is that root? Address is 10.0.10.0.10.24. Next hop type virtual experience. Next hop IP address 2. So we'll be creating virtual network. We'll be creating subnet, 2 subnet. Okay, we'll be having 3 subnets. Right. Because one will be default subnet, another will be another one we created, another 2 we created already. We will witness that with our eyes. So if I list now, it will display default subnet also, private subnet and DMZ subnet. So public subnet, private subnet, DMZ subnet. Okay. Now 10.0.0, 10.0.1, 10.0.2. Here in the root table 10.0.1 to 10.0.2. Associate the root table with the subnet. Paste. That's it. Address prefix 0. So let's see the description. As you implement a security strategy, you want to control how network traffic is routed across your Azure infrastructure. In the following exercise, you use a network virtual appliance to help secure and monitor traffic. You want to ensure communication between front-end and public servers and internal private servers is always routed through an appliance. You configure the network so that all traffic from the public subnet to a private subnet will be routed through a NVA. Public to private. What is the route? Okay. So if you see 10.0.10, 10.0.10 is a private to DMZ. it is saying routed through NVA. To configure network from a public subnet to a private subnet will be routed through NVA. DMG subnet from this. To make this happen, you can create custom route for the public subnet to route this traffic to perimeter network subnet. Later, you deploy NVA to the perimeter network subnet. Okay. So internet, it will go to the routing table address prefix 1010, and then it will go to the 10024, 1010 to 10024. Then it will go to the public subnet. Okay, I got it. Let's see the next chapter. We created the window. What is NVA? A network virtual appliance is consists of various like this: firewall, routes, load balancer, IDP, APS. You can deploy NVAs chosen from providers in Azure Marketplace, such as providers include Cisco, Checkpoint, Barracuda, Suppose, WatchGuard, and SonicWall. You can use an NVA to filter traffic inbound to virtual network, to block malicious requests, and to block requests made from unexpected resources. In the retail organization example scenario, you must work with security and network team. You want to implement a security environment that scrutinizes all incoming traffic and blocks unauthorized traffic from passing onto the internal network. You also want to secure both virtual machine networking and Azure services networking as part of your company's network security strategy. Your goal is to prevent unwanted or unsecured traffic network from reaching key systems. As part of the network security strategy, you must control the flow of traffic within your virtual network. You also must learn the role of NVA and the benefit of using NVA to control traffic flow through Azure Virtual Network. Network virtual appliances are virtual machines that control the flow of network by controlling routing. You will typically use them to manage traffic flowing from perimeter network environment to other networks. This is on-premise, and the UDR, it goes to the DMZ and then goes to the private zone DMG, and then it goes to the other. Okay. You can deploy firewall appliances into virtual network in different configurations. You can put firewall appliance in a perimeter network subnet in a virtual network, or if you want more control of the security, implement micro segmentation approach. With micro segmentation approach, you can create a dedicated subnet for the firewall and then deploy web applications and other services in other subnets. All traffic is routed through the firewall and inspected by the NVAs. You will enable forwarding on the virtual appliance network interfaces to pass the traffic that is accepted by the appropriate subnet. Microsegmentation lets firewall inspect all packets at OSL layer 4 and for the application aware appliances layer 7. When you deploy NVA to Azure, it acts as a router that forwards requests between subnets on virtual network. Some NVAs require multiple network interfaces. One network interface is dedicated to the management network for appliance. Additional network interfaces manage and control traffic processing. After you have deployed NVA, you can then configure the appliance to route traffic through a proper interface. User-defined routes. For most environments, the default system routes already defined by Azure are enough to get the environments up and running. In certain cases, you should create a routing table and add custom routes. Example include access to the internet via on-premises network using force tunneling. Use virtual appliances to control traffic flow. You can create multiple route tables in Azure. Each route table can be associated with one or more subnets. A subnet can be associated with one route table. Network virtual appliances in a highly available architecture. If traffic is routed through NVA, the NVA becomes a critical piece of your infrastructure. Any NVA failures will directly affect the ability of your services to communicate. It's important to include highly available architecture in your NVA deployment. There are several methods of achieving high availability when using NVAs. At the end of this module, you can find more information using NVAs in a highly available scenarios. What is the main benefit of using network virtual appliance? Yes. How might you deploy network virtual appliance? Great. Amazing. Let's see. Great. Our two answers are perfect. Um, the next chapter is an exercise. Let's go there. What we have there. 5 sandboxes for today. Oh, great. So, appliance. Okay. To build NVA, deploy Ubuntu LDN instance. We are creating network virtual appliance in subnet DMG subnet because we diverted our traffic from private to DMG, right? Then let's see what happens. Paste. Password should be. Let me see. Password. Must be 12 to 17. Oh my god. 4 3 is 12. Perfect. So we created a network virtual appliance. Now we have to do IP forwarding for the Azure network interface. The next step, IP forwarding for the NVA network appliance is enabled. When the traffic flows to NVA but is meant for another target, the NVA will route the traffic to its correct destination. So run the following to get the ID of NVA network interface. So NIC list from this group, we are taking VM, so we are getting the ID, then we are getting the NIC name. Enable IP forwarding for virtual network interface, NIC update. So we are going IP forwarding. So IP forwarding enabled on the network appliance NIC. Then we'll enable. Okay, what I did. Appliance, yes, it's a VM, right? IP forwarding, we need to enable IP forwarding on NIC. We are updating NIC to IP forwarding, right? Now we'll enable that on first we grab the IP address of network virtual appliance. Then we are running this IP forwarding to be enabled. PASSWORD@123. Right. Connection closed. Exercise, route traffic through the NVA. Let's see. Now that we created network virtual appliance and virtual machines, you will route traffic to NVA. Paste. Add the following configuration information to the file. With this configuration, the package installed when you create a new VM. This package contains trace routes utility that will use later in the exercise. Okay, let's see that. There will be some. Okay, go here, click on Control Q. Control S, Control K. The cloud shall run the following command to create a public VM, replace password with password for Azure account. Let me iterate 1, 2, 3. Create a private VM, replace password with suitable password. This is a public VM. Okay. It will take some time, man. 1, 2, 3. Same password will give. Run the following Linux watch commands to check VMs are running. The watch command periodically runs so that you can monitor the progress of VM. Let's see. The provisioning state value should be succeeded and the power state value VM running. Let's see. Great. Control Q, right? Control C. Amazing. Run the following command to save public address of the private VM to a variable name. Okay. Test traffic routing through the network virtual appliance. Run the following command to trace the route from public to private. When prompted, enter the password for Azure user. So, could not resolve hostname. Public IP. Where is public IP? Let me see what this variable has inside this. Public IP. Nothing is inside, that's why it's failing. Where is the public IP? Actually, we got private IP. Okay. Now if we do this, it will display. So we run only one. Now we'll do connect warning password @ 1, 2, 3. PASSWORD @ 1, 2, 3. What's wrong? What was the password? So like this, na? Control C. Paste @ 1, 2, 3. Connection closed. Trace route. Host key checking now. Trace route. Okay. So it is going from trace route to private 24214, right? Okay. So 24214. Notice that the first hop is 24. The address is the private IP address of NVA. Okay. Second hop is 14. The address of private. The first exercise, you added this route to route the table and link the table to public subnet. So now all traffic from public to private is routed to NVA. Okay, how is that? So routing table, it will come to 10.0.1, 10.1, 10.0.10. It will then go to the next hop 10.0.24, and next hop is virtual appliance. Then it will go to the 10.04. So let me go from first actually. So public IP address, it will go to the appliance, and then it will go to the network virtual appliance, and then it will go to the private IP. Run the following command to trace the route from private to public. It is directly going, man. Yeah, so the private VM is using default routes and traffic is routed directly between the subnets. So if it is going directly to the default route, and from there directly reaching. We have now configured routing between subnets and direct traffic from the public internet through DMZ subnet before it reaches to the private subnet. In the DMZ subnet, you added a VM that acts as NVA. You can configure this NVA to detect potentially malicious requests and block them before they reach their intended targets. Let's go to the summary successfully. So you learn how to customize routes in Azure Virtual Network and how to direct traffic flow through a network virtual appliance. You also learn how to create your own custom network virtual appliance by deploying virtual machine. Right. Yeah. Thanks for watching. Let's meet in the next session. Until then, bye bye.